So, yesterday I showed you multiple tables of multiple polyatomic ions where we learned the main five and then added oxygens and removed oxygens and changed the name slightly. And then we had a quiz on it. It turns out for many of these polyatomic ions, we can also add H's, and it slightly changes the name as well. And that's what we want to talk about right now, all right? Now, the difference between adding and removing O's and adding and removing H's is that our H's are coming with a positive charge. When we added and removed O's, they were just neutral atoms. They didn't change the charge on the ion. So when I added an O to chlorate and it became perchlorate, it was still a -1 charge, okay? But now we're going to add H's. So let's start with a very common one, and let's start with carbonate. Oops, what am I doing? CO3 -2. That's a mess, but you get the idea. I was thinking about the CH and the darn acetate that I was just talking about moments ago. CO3 -2. And this is carbonate. All right? We already know that. And now I'm going to add an H plus H plus. Hopefully that's not too confusing. It looks a little confusing on my note there, but you can write it such that it's a little smaller. And we're going to add an H plus to the front end of this little ion. And that's going to make it an HCO3. And it's going to change its charge. If I have a -2 charge and I add a positive charge to that, what's the new charge going to be, Dallas? -1. This is all good integers. So notice when we add an H plus to our negative oxyanions, the charge gets smaller, negatively smaller, by 1, because it's canceling out one of the charges. Does that make sense? Okay. And I'm going to add a second one to this. So I'm going to add another H plus. And what am I going to get there as my ion molecule? What am I going to result in when I add another H plus to that? What it's going to get? Yep, Brendan? And what's the charge going to be? Neutral. That's correct. H2CO3. Now, that's not an ion anymore. That's an actual molecule. That cannot bond with a metal ion to form a compound because it's already neutral. This actually is what we call carbonic acid. This is carbonic acid. All right? And I'm going to teach you after we talk about molecular substances how to name acids. But I kind of stumbled upon it by adding 2 H pluses to the CO3 -2. So I'm not worried about the fact that you know how to name that carbonic acid. Little bit of thing about carbonic acid. Carbonic acid is the acid that's found in pop or carbonated beverage, right? So if you take a drink of pop, you drink it down really fast, you feel the burning at the back of your throat, you say, oh, that tastes really good. And that's carbonic acid. That's what's burning the back of your throat there. If your pop goes flat, it's lost its carbonic acid, you drink it, it tastes like syrup, and it's not really good anymore, right? Okay. This is the thing I want to name right now, though. This is an ion. It's a negative ion, and we need a name for it. The name is easy. You got it from the back already, probably, right, Chris? Just hold on that other name. The name is easy. There's 2 versions of the name. This is called a hydrogen carbonate ion. Hydrogen carbonate. All right? It's called a hydrogen carbonate ion because it's made up of a hydrogen stuck to a carbonate. Ooh, ah. Not that exciting. There is another name for this ion as well. Chris, did you read it on the back?
No idea what
The piece of paper that has all of our ions on it. Maggie, what is it called? A bicarbonate ion. Or it's called bicarbonate. All right? Bicarbonate is the classical name. That's the old name, but it is used a lot. Hydrogen carbonate is the IUPAC name. It's very simple because it describes what it is. Let me talk a little bit about where this bi comes from in the bicarbonate ion. If you bisect an angle, what do you do to it mathematically if you're doing math and you bisect an angle? Does anybody remember from that geometry stuff way back when? Yeah, Emily? You cut it in half. You cut it in two. Compared to the carbonate ion, what did we cut in half to get to the bicarbonate ion, Atlee? The charge, right? We cut it in half. Okay? So bicarbonate is a carbonate that has half the charge because it's got an H on the front end. Okay? All right. Let me go over a couple more examples of this. This is just a new slide. We can do the same with any of the sulfates. SO4 minus 2. Notice it also has a minus 2 charge. I can cut that charge in half by adding an H. This is sulfate, and this right here, HSO4, what's the charge going to be if I've added an H plus? Yep, minus 1. I'm just drawing you through the same thing. Minus 1. What should we call this? Two possible names. I'll accept either or. Yeah. Yeah, it's a bisulfate. It's correct. What's the other possible name, Brendan? A hydrogen sulfate. And actually, hydrogen sulfate technically are two words, but it does describe one ion. Okay? And again, I'm not going to add the second hydrogen here. If I did, I'd end up with sulfuric acid, but we'll worry about that later on. Now, I'm not going to do the same for chlorate or nitrate. Why am I not going to worry about ions that have H pluses for chlorate or nitrate? Why am I not going to worry about those? Atlee? That's true. I can't cut the charge in half because I'd have a charge of like 0.5, right? What happens if I add an H plus to either of those ions? Brendan? They become the acids. That's correct. The charge becomes neutral, and I don't have an ion anymore. Let's take a look then at the last situation that I can deal with. What other ion can I add H's to of my big five that I've memorized? Maggie? Yeah, let's take a look at phosphate. PO4 minus 3. Phosphate. If I add an H plus, HPO4 charge, what's it going to be? You can just tell me. Negative 2. Negative 2. Can I call that a biphosphate? No, there is no biphosphate because I can't cut the charge of minus 3 in half. I can call this a hydrogen phosphate. They just called it hydrogen phosphate. Sometimes they called it, oh goodness gracious, monoacidic phosphate. There's all kinds of different things that you don't need to worry about, all right? We'll stick with the simple one for now. Hydrogen phosphate. I'm going to just put this below because I've got to do one more. Phosphate. So that's a hydrogen phosphate ion. The neat thing about phosphate is I can add a second one. H2PO4. And what is that charge going to be? Yep, -1. And now I need a name that distinguishes this from this. Yep. Yeah, dihydrogen phosphate. We're now going to pull out that prefix that we've used in things like molecular substances. This is a dihydrogen phosphate. Again, you might think that that's a big name, but again, it's just naming the negative chunk. When we do some examples, remember, there's always a positive name chunk and a negative name chunk, no matter how complicated that negative name chunk is. It's still naming the negative ion, all right? Before we do an example or two, let's just make this mean, because remember, we have all of the derivatives and the relatives. So I could have something like this. This is one of my favorite anions, by the way. It's just fun to name. H2PO2, -1. That is fun. Right there. Stare at it for a while. Tell me what the name of that thing is going to be. Oh, Dallas has already got it. This is exciting. Yeah, that's great. It's a dihydrogen hypophosphate, of course. He says as if, give me something really challenging. That was fabulous. That's a dihydrogen hypophosphate. There you go. That's a dihydrogen hypophosphate. I could put an ammonium with that on the front end. That'd be great. I'd then have ammonium dihydrogen hypophosphate. It's a great chemical. All right, let's put some together as some examples here. So the first two are just the ions. Name it. Give me the formula for the ion. Here we've got a compound, and look at there, we've got a dihydrogen phosphate. That's wimpy. Anyway, go ahead, don't wait for me, give them a shot. Now, when we get rolling on the rest of the course here, and we start using these in balanced chemical equations, and we start doing mathematics with them, I'll tell you right now, I don't have a single question that deals with ammonium dihydrogen hypophosphate, because ammonium dihydrogen hypophosphate is something that we don't just keep around. It's not like it's a common thing. Could it be made? Could I order some of it? I suppose I could, but I would have no use for it. There's a reason that the 5 that I make you memorize are the 5 that I make you memorize, because they're the most common that we come across. So when we get going and start doing, chemical reactions and start really doing chemistry, I'm not going to be asking you about ammonium dihydrogen hypophosphate. But maybe on a quiz tomorrow, just for fun, just to make sure you know the rules of naming, an ammonium dihydrogen hypophosphate may come across the board there. And same with when I do the test, this test for this section, and I give you that section on naming. I could be a little mean and stick the odd dihydrogen hypoarsenite, I guess, just to be mean. But don't completely freak out. I'm not going to give you 15 of those. Get one of those, just to see if you can put it all together, right? So again, don't completely get excited that, holy moly, look at all the stuff we're doing. I'm teaching you the naming system, but in the end, when we get going, it's going to be those main ones that we're going to be dealing with a lot in class. Okay, does somebody have a name for this first one here? It's an SO4 with -1 charge. It looks pretty run-of-the-mill to me. Pretty straightforward. What do you got? It's a bisulfate. Yep, bisulfate. And I got to put the pen down. Bisulfate. sulfate or a hydrogen sulfate, either or. Formula for a hydrogen phosphate. Somebody have a formula for a hydrogen phosphate? Emily? HPO3 minus 2 is correct, because we had to change that charge by 1. Excellent. Name of that compound. Again, there will always be two chunks to the name, the positive chunk and the negative chunk. There's the positive piece, there's the negative piece. Keep them separate, all right? Name that positive chunk and name that negative chunk. Chris, what do you got? Sodium, and what was the last part? Hydrogen sulfate? I'm sure you were correct, I just didn't hear you. I wasn't sure whether you said hydrosulfite, but it's hydrogen sulfite. Sodium, hydrogen, and that is a sulfite. Sulfite. And what else could we have said on the back end of that? Could have been something else as well. Yeah, Emily? Bisulfite. You could call it a bisulfite as well, right? So a sulfite, SO3 minus 2, can also be a bisulfite. Either or, I don't care. And iron 3 dihydrogen phosphate. Yeah, what do you got? PO4. Sorry? Whereabouts? At the very end, that's correct. Excellent. The common mistake on this is for students to think the iron is 3 and the phosphate is 3. But by adding the two H's, the charge of the dihydrogen phosphate becomes 1. So it becomes 1 and 3. That is correct. Nice job. All right? And just for the sake of talking about ammonium dihydrogen hypophosphite, just for fun, it's actually going to look like this. The ammonium is NH3, all right? And the dihydrogen hypophosphite is H2PO. If it's a hypophosphite, how many O's am I going to have on that? 2. The charge on the ammonium, all right, is +1. The charge on this is -1. And so that's the formula right there. It doesn't need the brackets, which means it actually would get written like this. NH3, H2, PO2. Question? Oh yeah, it is, NH4. Thank you, NH4, NH4. I make that mistake more often than not. Thank you, NH4. Now, again, you would look at something like that and say, I have no idea what that is. That's the craziest thing ever. But if you try to find those chunks, like I said, you've got the positive chunk and you've got the negative chunk, and so that thing is going to be made up of two names, ammonium dihydrogen hypophosphite. No matter how big and ugly it looks, the naming system is always binary. It's always made up of the two chunks. So when you're looking at something that looks pretty confusing, try to break it into that positive chunk and that negative chunk, and then name it. All right, one more last thing, and there's some practice problems, but I assigned you like 15, 16, and 17 yesterday, I think it was. Is that what I assigned you? So 13, 15, 16. So in other words, I can now add on 17 and 18 if you haven't looked at those yet. I don't remember what was assigned at that. You can put
17 was assigned.
It was long, so just 18. So just 18 is added on. The H's has the 18 in it. So it's just 18 that's added on to this. I've had different notes and I've done this in different orders, but 18 is the part that you're adding on at this point. All right? Okay? Now there's one more little add-on in terms of naming things. And that is called hydrates. And at this point, and even moments ago, I stressed to you that the naming system is binary. You always name the positive chunk and then the negative chunk. And now I'm telling you, there's a third piece sometimes onto these things. It's great. Chemistry does that all the time, by the way. You think you got something figured out, and then we throw a curve at you. But this is not too bad. This is a pretty simple add-on, because the only thing we're adding on always are water molecules. The only thing. You're never going to have anything other than that dot H2O behind it. So a few days ago when I talked about ionic compounds and how they're formed, trading electrons, becoming oppositely charged, sticking together into a lattice structure, repeating ions over and over again. It turns out that for some of these ionic compounds, as the crystal is being formed, if there are water molecules around, and very often when crystals are formed, there are water molecules around because they're formed by some evaporating water from a solution, and as it evaporates, the crystal crystallizes out and comes out of the solution. It turns out for some of them, as the lattice structure is being formed, copper, sulfate, copper, sulfate, copper, sulfate, that waters can get grabbed up and built in to the crystal structure. So there's actually some water molecules locked in to the crystal. It'll feel dry. It won't be wet in any way, but there will be actually 5 water molecules locked in for each copper sulfate. We call a compound that has water molecules locked into the crystal structure, we call that a hydrate. We say it's a hydrated salt. It means it contains water. Just like when you have lots of water, you're hydrated. When you don't have a lot of water, you're dehydrated. This can be heated, and that water can be driven off, and it changes the nice blue crystal structure into a gray powder, and we have created the dehydrate. Okay? We have to name the fact that whether we're dealing with the hydrated one or the dehydrated one. And so we have to add a little bit to the end of this name in order to tell us which one we're dealing with. Let's talk about how we're going to name this. Now, again, just put see table 68, or sorry, see page 96 for table 4 for the prefixes. This is the type of thing you've already seen before, and I might even get you to write it down, but later. Right now, you can make reference to it. These are the prefixes that you use to describe a certain number of atoms or molecules, or depending on what you're naming. We've already seen the di when we just saw dihydrogen. So mono is 1, di is 2, 3 is tri, 4 is tetra, 5 is penta. Now we're down here to ones that are pretty recognizable. Penta like a pentagon, 6, hexa, hepta, octa, nona, deca. All right? You've seen those before, right? Okay. So we use that in order to name this hydrate. So let's now name our, oops, I'm actually going to go back and name this guy right here. So if I just gave you the first part, what would its name be? And that's what we need you to do. Just name the first part. We've already got the name of that one? That's excellent. Maggie? Yeah, very good. That's copper 2 sulfate. Copper 2 sulfate. Positive chunk, negative chunk. Now I have to describe how many waters there are. 5. What was the prefix for 5? Chris? Penta? And we call this Pentahydrate. That was a Y in there, terrible Y. Pentahydrate, all right? Penta means 5, hydrate means water, so we would call that particular crystal copper 2 sulfate pentahydrate. That's how you do it. That's the only add-on. Different chemicals can incorporate different numbers of water molecules. Depending on what the number is, you put a prefix on it. So if we jump ahead here then to some examples, I've got one name, I've got one determine the formula, and then I give you the last bit of homework problems. I give you a summary sheet with all kinds of extra practice, and you practice. Again, I've got all these extra words, provide the formula for, right, name, formula, you get the idea. Make your notes as compact as possible. It'll make studying easier. Don't worry about all these extra words sometimes. I'm hiding the prefixes up here for reference. Somebody have a name for that one on the top? We got a name. Dallas, what do you got? Yep. Calcium chloride, and I'm running out of space, but it would run along there. Tetrahydrate. Excellent. And the formula, Chelsea, what do you got? DCl2. Yep, 6H2O. That's a nice, easy way to end it. Easy add-on there. Okay? Everybody got that? So again, a couple more questions to finish that off with. And as I said, I got a little review. Well, it's a summary sheet. And you really can only do the front half. The second half is for molecular compounds, when we do the molecular compounds, so you're doing only the front. And I don't think I have the solutions for this, so this is the type of thing that you can compare with neighbors. This, again, it's just a practice. I actually found it online, and I thought, hey, that's a handy sheet. So you obviously can do 1, name the ions, 2, name the compounds, 2A, name the compounds, B, write the formulas, and then 3 are binary molecular compounds. We're not doing that yet. And same with the back, it's going to have acids on there. And then number 6 is like a great big review at the end. No, just do the front page, and you're stopping, you're not doing 3. All right, everybody okay on that? And tomorrow we will have one more quiz, and it will encompass everything, and it's going to be a little bigger. It'll likely be 10 and 10, and I'll have it on a nice little piece of paper, so that's a little more formal since we've kind of wrapped everything up. All right, it's going to be the same type thing. Okay, and you can work away till the end.